Fingerprints are a staple in crime dramas and detective stories. They are the key to unlocking hidden identities and solving mysteries. But can the fingerprints of the dead be as reliable as those of the living? This question has intrigued both scientists and the general public for decades. In science fiction, fingerprints never lie. Yet, in real life, the story is more complex. The state of a person's fingerprints after death can vary greatly. This raises questions about their reliability in post-mortem identification. Our journey begins by exploring the science behind fingerprints. So, let's dive in and uncover the fascinating world of fingerprints. Fingerprints are formed long before we are born. By the time a fetus is about 10 weeks old, the ridges on their fingertips start to develop. These ridges create the unique patterns that will become their fingerprints. This formation process is influenced by genetics and environmental factors in the womb. Each fingerprint pattern is unique, even in identical twins. The ridges and shapes are determined by random physical stresses and pressures. This makes fingerprints a powerful tool for identification. Understanding how fingerprints form helps us appreciate their uniqueness. It also sets the stage for exploring what happens to them after death. Fingerprints are not just unique, they are also permanent. Once formed, they do not change throughout a person's life. The ridges may grow larger as the person grows, but the pattern remains the same. This permanence is crucial for their use in identification. The structure of skin plays a key role in preserving fingerprints. The epidermis, the outer layer of skin, is constantly regenerating. However, the dermal layer, where fingerprints are formed, remains stable. This ensures that the patterns are preserved even as the outer skin changes. Injuries and burns can damage fingerprints, but they often heal back to their original pattern. However, as we will see, the post-mortem state of fingerprints can complicate things. After death, the human body undergoes several changes, both internally and externally. These changes can significantly affect the state of fingerprints, which are crucial for identification. Factors like decomposition, drying of the skin, and external impacts play a major role in altering the prints, making forensic analysis more challenging. Decomposition begins shortly after death, starting a complex process of body decay. The skin starts to break down, and the ridges of the fingerprints can become less distinct, complicating identification. This process is heavily influenced by environmental factors such as temperature and humidity, which can accelerate or slow down decomposition. In some cases, fingerprints can remain recognizable for weeks. In others, they degrade quickly, depending on the conditions. Drying of the skin or desiccation is another critical factor that affects fingerprint preservation. As the body loses moisture, the skin can shrink and harden, altering the fingerprint patterns. This can distort the fingerprints, making them difficult to read and analyze accurately. Despite these challenges, forensic scientists have developed advanced techniques to recover and analyze these altered prints, ensuring accurate identification. Fingerprints are a vital tool in criminal investigations, providing a unique identifier that can be crucial in solving crimes. They help identify victims, suspects, and even solve cold cases that have remained unsolved for years. The use of post-mortem fingerprints adds an extra layer of complexity and precision to these investigations. In cases of unidentified bodies, fingerprints are often the first step in identification, offering a starting point for further investigation. Forensic experts meticulously compare the prints with extensive databases to find potential matches. This process can provide crucial leads in missing persons cases, helping to reunite families or bring closure. It also plays a significant role in identifying victims of crimes or large-scale disasters where other methods may fail. Post-mortem fingerprints are also used to link suspects to crime scenes, providing a timeline of events. If a suspect's fingerprints are found on a deceased victim, it can be strong evidence, often pivotal in court. The reliability and accuracy of post-mortem fingerprints make them an invaluable tool in forensic science. However, the process requires careful handling and expertise to ensure the integrity of the evidence. Forensic scientists must work quickly and efficiently to preserve the prints before they degrade, ensuring they remain usable for analysis. Real-life cases highlight the importance of post-mortem fingerprints in solving crimes. These cases demonstrate the practical applications and challenges of using these prints in investigations. One notable case is the identification of the victims of the 9/11 attacks. Fingerprints played a crucial role in identifying the remains of victims. Despite the severe conditions, forensic experts were able to recover and analyze prints. Another case is the identification of John Wayne Gacy's victims. Gacy was a notorious serial killer and many of his victims were unidentified. Fingerprints helped forensic experts identify several victims, bringing some measure of justice to their families. These real-life examples show the power of post-mortem fingerprints. They highlight the importance of preserving and accurately analyzing these prints. Preserving fingerprints after death is a crucial part of forensic science. It ensures that vital evidence is not lost. The condition of the prints can significantly impact their usability in investigations. Clear, well-preserved prints can lead to quicker and more accurate identifications. Several methods have been developed to preserve and restore post-mortem fingerprints. These techniques are essential for maintaining the integrity of the evidence. One common method is rehydration. This process involves adding moisture back into the skin. When the skin dries out, the fingerprints can become distorted and difficult to read. Rehydrating the skin can restore the ridges and patterns, making the prints legible again. This is often done using chemical solutions that soften the skin, allowing the ridges to reappear. Once rehydrated, the prints can be lifted using traditional methods such as dusting with powder or using adhesive tapes. Another technique is the use of cyanoacrylate or superglue fuming, which is highly effective. This method involves exposing the fingerprints to cyanoacrylate vapors in a controlled environment. The vapors react with the moisture in the prints, creating a hard white polymer on the ridges, which preserves the details. This makes the prints more visible and easier to analyze, providing crucial evidence for forensic investigations. Technology plays a crucial role in fingerprint analysis. Advances in imaging, software, and databases have revolutionized the field. These technologies enhance the ability to analyze and match fingerprints, including post-mortem prints. One significant advancement is automated fingerprint identification systems, or AFIs. AFIS databases store millions of fingerprint records. They allow forensic experts to quickly compare prints and find matches. This technology is essential in identifying both living and deceased individuals. Imaging technology has also improved fingerprint analysis. High-resolution scanners and cameras capture detailed images of prints. These images can be enhanced and analyzed using software. This ensures that even degraded or partial prints can be used effectively. The role of technology in fingerprint analysis cannot be overstated. While post-mortem fingerprints are valuable, they come with limitations and challenges. Understanding these challenges is crucial for accurate analysis and identification. One of the main challenges is the degradation of prints. Decomposition, drying, and external impacts can distort the ridges. This makes the prints difficult to read and analyze. Forensic experts must work quickly and use preservation techniques to mitigate this. Environmental factors also play a significant role. Temperature, humidity, and exposure to elements can accelerate degradation. Bodies found in water or exposed to extreme temperatures present additional challenges. These conditions require specialized techniques for print recovery. Another limitation is the availability of fingerprint records. For identification to be successful, the prints must be compared to existing records. The field of fingerprint identification is evolving. Technologies and to enhance the process. These advancements hold promise for improving the use of post-mortem fingerprints. One exciting area of research is the use of artificial intelligence. AI algorithms can analyze and match fingerprints with high accuracy. They can also learn from patterns and improve over time. This technology has the potential to revolutionize fingerprint analysis. Another promising development is in imaging technology. Advances in three-dimensional imaging and scanning provide more detailed and presentations of prints. These technologies capture the small details and reliability of analysis. Biometric databases are also expanding. Efforts are being made to create comprehensive global databases of fingerprints. Fingerprints are a remarkable aspect of human biology. Their uniqueness and permanence make them a powerful tool for identification. Even after death, they continue to provide crucial information in criminal investigations. The journey of fingerprints from formation to post-mortem is fascinating. Understanding this journey helps us appreciate their reliability and limitations. It also highlights the importance of preservation and accurate analysis. Real-life cases demonstrate the practical applications of post-mortem fingerprints. They show how these prints can solve crimes and bring closure to families. While challenges remain, ongoing research and technological advancements hold promise. In conclusion, the fingerprints of the dead do work.